Take it away.
Thank you. Welcome, everyone. So, some few practical things before we get started, such as in the case of a fire or something like that, we have emergency exits. Same way you came up, nothing particular there. After I've spoken, I will be handing over to Fredrik, and in the meantime, if you want to visit the bathroom or something, you have it out there towards the right in the corridors. You have a handful of bathrooms. But yeah, like Shane said, today or this month, it's Cybersecurity Awareness Month, and that's something that we at Concede has been thinking a bit about as well. Because Concede, we are an IT consulting company, right? We are about 1,800 consultants. We have a lot of offices here in Sweden, about 45, 50. And we also have businesses in Norway, Denmark, Poland, and Germany as well. Me personally, I'm from the Linköping office, but we here at Concede, we work broadly, right? It's not only that we are focusing primarily on cybersecurity. We're a broad consultancy firm, and our big idea, so to speak, is to see if we can actually accelerate visions and try to do some sustainable digitalization. So it's anything from software development to communications aspects, project management, change management, basically whatever we need in order to provide digital solutions to our companies. And in this month, for example, we've been trying to do some more work with cybersecurity. So something that we have done and tried to provide for friends and family is an event that we have had for all of our friends and family to just go over some basics of cybersecurity. Us here in this room, of course, we are pretty much well versed within the area. We're actually here at an OWASP event, right? But not everyone is aware of those things. So we've done one of those events. But my topic today will be talking a bit about the principles of secure development. And first, a brief introduction about me, who am I, and my background and my interest in this area. So, like I said, my name is Johan. I'm working here at Concede as a cybersecurity specialist. I'm also a guest here at Stockholm. I normally live and work from the Linköping office. I have a broad focus, but my background is as a systems developer. Moved on to working with systems architecture. I've done a lot of penetration testing, and many times working with customers that have very high security requirements. Some of the customers that I've been working on for the last couple of years can be seen here. So today I wanted to talk a bit about my experiences and what we can do as software developers when we're thinking about building new solutions, deploying solutions, and maintaining them over time. And that is where it comes into some principles of secure development. So today we're going to be talking about a broad range of topics, things like being aware of the importance of cybersecurity, both in terms of who is responsible for cybersecurity, who is the main concern when it comes to system development and cybersecurity. How can we work with knowledge and keep that sharp? How can we work with security in terms of our actual coding? How can we do it when it comes to development environments and different staging areas within development? Same goes for how we're hosting our code, how we're building and deploying our solutions, how we're working with tests, and how we can, from a system development standpoint, think about issues that could occur. So starting off then, who is responsible for cybersecurity? Well, when we think about actually developing solutions, we have a lot of different roles, right? Me, as the systems developer, I might be the one doing the code. But then we have a business analyst working with requirements from the business. We might have an architect, we might have a product owner, a project manager. There's a lot of different roles that go into the development of software, right? It's not only about writing the code as a developer. So how can we think about security from these different perspectives then? Because in the end, not any single one of these roles can bear the full responsibility of building secure solutions today. So for instance, myself then, as a developer, well, sure, I have to contribute to building secure solutions as well, right? I have to ensure that I'm aware of secure coding practices. I need to ensure that my system and my code is protected against vulnerabilities and different exploits. So I need to be aware of different best practices. And this can take time, right? Because time is one of the resources that we actually need to build secure solutions. We need to ensure that our developers actually have time as a resource when it comes to mitigating different threats. And that sort of transitions then again into who decides time? Who can decide that the developer should have time to actually secure and make sure that we have robust solutions? Well, perhaps then from a project management standpoint, we need to ensure that we have security as a part of the project plan. Security cannot be an afterthought in the project. It has to be there from the very early onset. And we need to think about security risks and these procedures from the start of the project to the finish of the project. Perhaps we're doing a handover from project to maintenance. It has to be involved throughout this life cycle. So when it comes to project requirements, it's not about these functional requirements that we need to press the button and the button should become blue. It's all about these other things as well. We need to specify which security measures to be implemented. Which sort of compliance requirements do we need to adhere to? What is the purpose of the system? What sort of information should the system hold? And ensure then from a project management standpoint that we are actually testing these things throughout the development process. And again, from my experience when I've been working with various different companies, it's often that we have a product owner inside the business. That product owner might have the final say, might be the one controlling the budget, might be the one sort of setting the very high level requirements of what are we trying to build. Are we trying to further develop something that already exists? Are we building something new from scratch? So as a product owner as well in this part, there is a responsibility for security as well, to sort of emphasize the importance of these topics. And then ensure then that the project or the solution actually implements the requirements that are needed. And that comes into a lot about testing, something that we'll be talking a bit more soon in a couple of slides. But we need to ensure that we have test and quality assurance being aware of the security features as well. Again, to this purpose of not only doing functional test requirements and writing user stories and test cases for functional requirements. And it can be sometimes in a larger project development team, we might have a dedicated person who has the test and the QA hat on it, so to speak. Sometimes it might be us developers doing the tests ourselves. It all depends, right, on how big the project is. Am I working alone as a developer or something? Are we a team of 2 or 3 people? Or are we, say, a team of 15 people? But essentially, even if it's a dedicated person or if it's a role that is shared between the different members of a project or development team, we need to ensure that we are reviewing the code, identifying potential risks, and then provide feedback, right? But a lot of times when I'm talking to developers and those building systems, they seem to have a bit of a narrow approach only to the creation part of our software, to when we are coding the software. But we're building solutions for them to be used, right? So what happens after we are done developing? Once we have deployed it, once we're supposed to maintain it over time, perhaps we need to think a bit about the roles of a system administrator as well when it comes to development. Because, I mean, we need to ensure that systems are configured securely, right? Perhaps we need to do patches and updates if we're doing regardless if we're hosting things on-prem on Windows or if we're doing a cloud solution, things needs to be managed over time. But regardless from which perspective you might have your own association when it comes to software development, the importance here is getting all of these different views into a project. And that's the importance then of collaborating perhaps from different perspectives on how we can produce secure solutions. I, as a systems developer, might have one specific view of security. My project manager might have a different view of security. The product owner in the business might have a completely different view about security, and sometimes perhaps not even having a view of security. So we need to share this knowledge and expertise to actually build the solution in the end, right? I like to say that you can't simply put 10 developers in a conference room and leave them there for 3 months and then have a secure product in the end. We need to have more perspectives into that process. And that comes down a bit to knowledge, right? How do we know how to make things secure? And then it's all about how are we keeping ourselves up to date? I mean, sure, if we're to build solutions that can actually withstand attacks from today, we need to be aware of defensive security practices. So we need to keep our level of knowledge up to date. It's constantly evolving, right? The threats we consider to be the most relevant 5 years ago perhaps mean nothing today. And perhaps in yet another year forward, we might have completely different threats out there that we as developers need to be aware of. So when I'm talking to developers, I try to basically say 3 different things. Well, we need to be aware of common security threats, right? Everyone that's working with software development nowadays should be aware of sort of common attack methods. What is injection, for example? What is a man-in-the-middle attack? Again, perhaps simply going over the OWASP top 10 list. That's something that I normally do with my development teams, ensuring that everyone, regardless of their role, is aware of it on a high level. Sure, some people might need to have very specific knowledge about different things, but I think everyone, regardless of their role in software development, should be aware of the different threats that might be facing our solutions. And when it comes to building secure solutions, we need to be aware of, okay, what sort of building blocks do I have available? What can I use to incorporate things into my solutions that I'm coding to make them robust and make them secure? And here it's all about perhaps knowing what exists out there. Do I need to create my own building blocks? Or can I sort of see what are available out there? There might be very good open source alternatives, might be good packages for different code languages that can sort of help me focus on my core concept. I, as a developer, perhaps don't need to build my own hashing algorithm, but I, as a developer, need to be aware of what different options are there out there. Which option is the good or the sound option for my specific development case? And one of the largest flaws today is when it comes to sort of identity or authentication authorization. A lot of times when I'm reviewing code or testing applications, I see sometimes people are taking some shortcuts every now and then. Oh, we forgot to put up authentication on this specific API route, or we didn't really test the permissions level good enough in our systems. So we need to be aware of some common authentication authorization methods. And this can be done through various ways, right? It can be done about reviewing what other people have done, what's trending out there. I personally like to try and review sort of security incidents that have occurred, right? What have other software, how have they been attacked? Have they exploited any specific flaw in a shared component, or what might be the case? And how this is actually done on a practical level then, well, that can vary a lot. It can be everything from reviewing different forums, discussing with other developers, participating in great events such as these. But we need to ensure then that we also maintain these knowledges over time. Perhaps a software development team needs to incorporate some of this continuous learning into their daily work. But in the end, when we are developing systems, a lot of things comes down to code, right? Some solutions might have thousands upon thousands of lines of code. And here it's quite important then to perhaps talk about the boring stuff about software development, ensuring that we have clean and maintainable code. It might be super obvious, but at times there are shortcuts that are taken, perhaps unnecessarily. Might be due to a lack of time, a lack of attention, or a lack of review. But in essence, if we have sort of not the best code, we can have complexity in our systems, right? And complexity in these cases may result in different bugs, and then that might result in different vulnerabilities. What if we're a big development team of, say, 10 or 15 people working on one repository together, one large project, and people are going in and out of the project over a couple of years, and there's not really any consistency in how the code was written. We don't have a common design structure on how we want to build the projects. That might then result in complexity. Because again, as the attacker out there, they only need to find one specific way in, whilst we need to guard ourselves for every single purpose. So what can complexity be then? Well, it might be that we don't really have any good standard of how we are naming things, like classes, methods, functions, and so on. We might not have the conventional structure inside a project. One developer who has been working on a project might have their own way of doing things, and then another developer comes in who has another idea of how we want to build the structure. We might not have any documentation. Sometimes we don't need a 30 pages, this is how the system is built, but sometimes it might be good enough to just have inline comments, right? Just to provide some sort of context for the next developer who's working on the system. And again, that different contributors might have their own individual styles. And it comes down a bit to two things here, right? Perhaps we need to come together and then decide within our project what is the standards that we'll be working towards. How can we together decide this is how I want to code? And how can we then ensure that we are working together to ensure that we're actually following that standard? And the same thing goes for when we're updating things, when we are continuously working with our software. Perhaps releasing version 1, and that's the MVP. It's something to get us started. We need to add more features, we need to fix bugs, and so on. So yeah, when we are doing these different changes over time, then perhaps we need to do some peer review. Make sure we adhere to our coding standards and do small and regular commits. But when we are talking about development as well, we need to think about our staging environments. So we need to think about, as a developer, I want as much freedom as I can. I want to do rapid iterations. I want to try things on the fly. I want to shoot and see what sticks. So there's often this conflict then about usability for me as a developer. In the very extreme ways might be that I have unlimited access to everything that I want, unlimited access to the different systems that we are supposed to do integrations with. But on the other hand, we can't have such openness, right? We need to have some strict guards for how we are protecting environments. So this is a bit of a conflict here. And how can we solve this conflict? Well, it's a hard question, but we need to be flexible. But at the same time, we need to be secure. And it's not about that we don't want our developers to be efficient. Of course, we want developers to be productive, ensure that they have the proper prerequisites to actually deliver good solutions. But it's about understanding the different risks that we might have in terms of staging environments. What are the risks, perhaps, from a development environment to integrate directly to the production database? What are those risks? So we need to trust the developers, but we need to verify their actions as well. And that means that perhaps we need to do some extra protective measures. Perhaps we can't simply throw credentials and secret keys around within the development team. We can't store them in all the different staging environments and having them be the same. And like I said, we can't really do operational procedures from a production system or towards a production system from our development environment. So how can we translate this to some sort of practical scenario then? Well, like I mentioned before, I've worked with a lot of different companies and a lot of different development teams, and sometimes you need to sort of take a step back, right, and think, how are we actually working across our environments? So let me paint a picture here. Say, for instance, that I, as a developer, I have my own local development machine, right? I have all the resources I need to do some rapid prototyping. I might have my user stories or my tasks that I need to get done. I have a specific bug to fix. I have a new feature to develop. And, well, in my own context, I need to be able to test things rapidly, deploy whenever I want, and just try things out. And then whatever I've tried, well, do we have any conflict with what my coworker did on the other side of the table? Perhaps we can then do a functional test environment where we test all these different things together. The features that I've been working on together with what you've been working on or what you've been working on. And here we might then start to add more people into the mix as well, right? We can already here get some early feedback on what we've been building. We can come up with new ideas and do rapid tests as well. So perhaps here we can also have a large degree of freedom. And then perhaps we might have a more traditional user acceptance test environment. It might be more dedicated and more similar to a production environment. We might have more stakeholders. We might have more eyes on the target. And then we have production, right? Where everything is fully fledged out. We have all the users, all the data, and all the security measures. But should we only really think about security here towards the very end? Should we only think about security measures in the production environment? What happens then if we are building things in development? We're testing them in functional tests. We are proceeding to user acceptance tests. And then there is a conflict between the security measures that we have implemented, perhaps different configurations or security-related products that might cause issues. So we need to try and move this security way of thinking further down the line. Now, of course, we can't perhaps realistically have the very same security level down at the very bottom of the development staging area. But there are various different things that we can think about here when it comes to staging areas. And a lot of things, when I'm working, like I mentioned before, I perhaps want this freedom of logging in wherever I want as a developer to do my job. But perhaps we need to have some sort of access controls in the earlier stages as well. Perhaps we need to have some sort of access control on the development machine as well. Perhaps I, as a developer, need to set up a few different test accounts to verify different functionality in terms of authorization controls or access controls. And also the topic about data sensitivity. Because again, when we're talking about protecting information, right, it's all about which information is worth protecting. We can identify that. We can apply different security measures. But then again, if we're only focusing with those security measures on a production staging environment, what if we then do, well, for the sake of it, let's make it easy for us. We can just do a copy of the production database, send it down to an earlier staging environment, and work with the data there. But if we don't have the security features in those environments, well, we might have some risks here. It might be that we need to work with dummy data and have a way of actually producing sort of realistic data, but not the real sensitive parts that are outside in the production environment. And perhaps we also need to think about it from a networking perspective. Should a functional test environment be able to send queries to a production database? Well, perhaps we can sort of restrict that so it's not even possible from a network perspective. Regardless if we're working in, say, Azure architecture in the cloud or on-prem in a sort of a Windows enterprise environment, we can sort of restrict it from a network perspective as well. And the same goes for testing, right? If we have more security features early on in the staging environments, we can perhaps do testing related to the configurations and the integrations of our solutions that we have developed with the different layers we're adding on top of it. And it's also a perfect case to do some disaster recovery scenarios. If we have more of the features down the line, we can do some better results. All good. But it's also about where we are storing our code. We need to ensure that we think about the different repository services that we are using. Because, say for example, if someone has malicious intent and is able to access our code and change it or do some sort of a manipulation of it, that in turn then might lead to actual severe cases in the production environments. So we need to think about which repository we're using. Do we trust that repository? What's the exposure of that repository? Are we using a public cloud service? Are we hosting it open as open source on GitHub? Who has insight to the code itself? Is it sensitive? Do we need to actually hide it? Do we need to host our own repository service? And also ensuring that we're protecting access to the repository as well, right? It's not only about ensuring that the production servers are safe from access, it's about securing the code as well. And unfortunately, I still come across examples from time to time where we are actually coding in secrets and service credentials into the source code. And obviously, they should not be there. They should be stored somewhere else in a secured key vault or environment variables or something like that. And I also see from time and time again in these larger companies where developers perhaps go in and out of projects over time, that we are not revoking their access to the repositories. I've seen examples where a developer who hasn't worked in the project for 2 years still have full access to the repository, can change whatever they like. And again, like I mentioned before, we need to ensure then that all the code changes that are made into our repository are checked, so we don't end up feeding a supply chain attack down the line. And same again as we're thinking about, so yeah, we need to think about the security measures from how we're handling the code as well. It's not only about securing our environments or securing that the code we write is good. We need to think about who can access and manipulate the code. And that also goes further down the line, right, to how we're thinking about deploying code. Sure, we can do a lot of good work when it comes to how we are building the code, how we are writing it, ensuring that we are aware of different threats. We have selected good security components to mitigate all the different threats. But we also need to think, how are we moving from my Visual Studio out to the production environment? How can we think and work with security along a build and deployment pipeline? Well, there's various ways we can talk about security here, right? And we should try to automate as much as possible inside the pipelines. We can do static code analysis along the way. We can do dynamic tests towards different API services or so on. So we should try and think, what do we need to do from our push to how it goes into production? What can we do here? Perhaps something that I've seen a lot of times when people are doing tests in a build and deployment pipeline, they are yet again perhaps more focused on the functional test requirements. Is the API returning the correct data based on a given input? Well, that's great. Sure, we need to test those things as well. But can we also test for vulnerabilities in the same sort of pipeline? But like when we're talking about code repositories, we perhaps need to think about the different pipeline services that we are using. We need to ensure that we have good insights into the pipeline, that we are controlling it. And we need to know, how are deployments triggered? Should anyone in the development team be able to push a button and send code directly into production? Sometimes perhaps, other times perhaps not. And this comes back to reviewing things together and avoiding the concept of self-policing, right? If I'm the sole developer writing the code, doing the testing, pushing everything to a branch and then deploying it, well, there might be risks of human errors along the way. So perhaps we also need to think about, how can we control how a deployment is done? Do we need approvals from different people? Are the developers themselves, do they have the mandate to say that things go to production? These are the topics we need to think about. And these are often things that are sort of left out when I'm talking to a lot of development teams. They're thinking about security in various aspects, but not entire chain. Because how we are releasing things might be complicated at times. Don't worry, I'm not supposed to go over the entire graph here, but this is just an example of branching strategy, something like that. How do we think about branching strategy, deployments, securities, testing? And here it's not that there's only one simple solution that's applicable for every single development team or every single project. But as a development team, perhaps we need to sit down and talk about this. How are things supposed to be released? If we have an emergency issue that we need to do a really quick deploy, how do we think about that? And here it comes perhaps back a bit to the very first principle about the different roles we have in a development team, right? Who is involved in all of these different things? Is it the same person who is doing everything from coding to deploying, or perhaps in larger organizations this might be historically separated a bit? So yeah, when we're thinking about deploying things, when we're thinking about what's the responsibility for a developer, what's the responsibility for the system administrator, perhaps managing the environment where everything is running. And again, it comes back to this, like having a joint perspective, right? I, as a developer, need to be aware of what happens after I've pushed it into the correct branch. And perhaps if we have separate responsibilities, a system administrator perhaps needs to be aware of how can we then take different monitor inputs and issues that occur in production environment and ensure that they are feeding back to a loop. And a lot of these things then comes down to, how can we test security? Well, as you all know, we can do security testing in a lot of different ways, right? And perhaps traditionally we have sort of relied too much of a point-in-time assessment. We need to deploy this new solution that we've been working on for a year. Oh, right, but before we go into production, we need to do a serious security test here to make sure it's up to snuff, right? So we might do a manual and resource-intensive, but thorough and well done penetration test. But if we do it only at the time of release and then our product continuously evolves, we add new features, we fix bugs and so on, this point-in-time assessment might decay, but our code might evolve. So we might have a discrepancy here from the test from the actual thing. And this comes back then to what I mentioned before about sort of integrating the purpose of testing into the development lifecycle, into the deployment process. What can we do in terms of automation? Sure, perhaps an automated test can't replace every thorough angle a senior penetration tester might throw at the system. But perhaps we can reduce repetitive work. Perhaps we can take advantage of what humans are good at and what computers are good at. For example, simple things like checking, do we have any dependency in our project that might have a vulnerability? Something that can easily be automated, but we need to think about it and ensure that we're actually doing these things. And then try and integrate that with our pipelines. Now, what can we do in terms of testing then? Well, there's various ways to test software, right? We can think of it as the static analysis and the dynamic analysis. We can sort of simplify it by saying that the static part is a sort of a white box approach. We have all the information before. We have the source code. We know the underlying framework, we know the design, how it's implemented and everything. We're testing it sort of from the inside out. Sort of the developer approach of doing the test. Or when we're talking about the dynamic part, perhaps we're testing things in runtime. Perhaps that specific test doesn't really have any knowledge of the various technologies used or the different frameworks that the application is built upon. Sort of a outside-in perspective. And when we're setting up all these different things, well, they have prerequisites as well, right? Well, you can't really do a static code analysis without the source code. And you can't really do a dynamic test without actually running the application. And these things are good for various reasons, right? I mean, sure, the static code analysis might be done very, very early in the development stage. And it might be able to find problems that are easily fixable. And perhaps if we're finding things more towards the end, it might be harder to fix them, might be more complex. But regardless, we need to think about security in this entire process, from the very first week of a project towards the very end. And we need to think about both when we're doing manual testing, because that's still good, right? But perhaps we need to also do more continuously. So we're testing our applications all the time throughout the life cycle. But regardless of how much planning we are doing, how much security measures we're implementing, we still might have security issues, right? Because when we are developing software, of course, the first priority is to build the function that has been requested, to produce some sort of value, to perhaps identify if a concept is working, if our minimal viable product is what has actually been requested. And at the very start, yeah, perhaps we don't really do so much about robustness or security-rated functionality. And regardless then if we are thinking about security from the very start or towards the end, if we are only thinking about security at the very end, we might have a large backlog. But at the same time, if we're doing it only at the start. Right, so at the very start of a development, sure, we might not think about every single security angle, but we might then create a security debt. But we need to keep track of this, right? We need to perhaps maintain a bit of a register. Perhaps we need to think about the different things and prioritize them in the project. Perhaps we can't do everything at the first week, but perhaps we shouldn't do it the very last week either. And just one example of this that I often see is, from a development standpoint, we are very early to introduce debug loggings, right? We want to ensure that things are working. But when we're thinking about the debug loggings, well, can we perhaps already at that point start to think about what actual logs towards the end do we need to produce? Perhaps we have a requirement based on the information we have in our system to have logs available. Perhaps we're supposed to ship those logs to a central log management service. We can start to think about these things from the early onset. So, regardless of how much we are preparing ourselves and how good we are at following these best practices, we still need to have a plan for when things go south. So, we need to have a plan in place, right? How do we respond to these incidents? And sure, in larger organizations, we might have a information security team that handles all of that, sort of a SOC service or whatever you like. But these things might then boil back to us as a development team as well. How do we respond to these things? How do we issue emergency changes? How do we fix things that are incredibly severe? How do we respond to these incidents? Do we have a plan in place? And who are the ones that are supposed to actually end up fixing it? Is it supposed to simply enter the Jira backlog at the very bottom and then someone will take it when they have the time? Or should we talk about when we have security incidents? Do we need to create a dedicated response team? Who are the key stakeholders that needs to be kept in the loop? And are we as developers aware of the different tools and processes then to respond to these things? Because if I were the product owner of a solution, I'm located in the business and I have a vast interest in ensuring that this service is up and running and that this information that's kept there is being kept secret. Perhaps I need communication then with the development team, and I need some sort of transparency. And these are the things that perhaps need to have some sort of consideration before it actually happens. How are we going to communicate? With whom? How often? And then perhaps we need to learn something as well. How can we prevent similar incidents from happening in the future? And sure, this can be thought about from different perspectives. Large company might have their continuity planning and their security team handling these big disasters and big disaster recovery and these large crises. But we might also have smaller issues that are still, for us as a development team, very important to solve. So these are some things that we need to be aware of and simply have in mind when we are thinking about security and software development. So again, it's not only about code, right? It's not only about ensuring that the developer is doing the correct code and have input validation in their APIs or whatsoever. We need to ensure that we're thinking about security throughout the life cycle, from requirement to maintaining and updating everything along the way. So these are some things that I would like more developers to have in the back of their mind when they're thinking about producing secure solutions. So that's it for me, everyone. Thanks.